Welcome to six-part series on numbering system. In this six parts, what we are covering is in the part one. Part one is all about introduction to systems, where we'll be covering overview of numbering system and concept of base or radix. Part two is decimal numbering system, where we'll be covering understanding the familiar base 10. And part three is all about binary, how computers use zeros and ones to represent the data. Part 4 is about octal and hexadecimal, using an octal and hexadecimal to simplify long binary numbers. Part 5 is all about converting from binary to binary, decimal, octal, and hexadecimal. And part 6 is finally will be covering practical use of number system in memory, CPU, programming, and more. Watch till end. You will see a lot of new things, no new nuggets. Let's begin with part 1. Everything a computer does comes down to numbers. Everything. Computers use their own numbering system, that's binary. This series explores how computer thinks in numbers. What is a numbering system? Numbering system, a way to represent numbers using symbols or digits. There are many numbering systems. Examples, decimal use 10 symbol, deci means 10. So 10 symbols, and the symbols are 0 to 9, not 1 to 10, but 0 to 9. What are the components of any numbering system? Something it's called base or radix. What is base? Tells how many unique digits are used, how many unique symbols are used, set of digits. For example, decimal uses digits 0 to 9, binary 0 and 1. And another thing is place value. Place value, position of digit determines its value. One may be in one place might be value of 1, and another place it might be value of 128. So for example, in decimal 345, it's 4 is in tens place, so it's multiplied by 10. 3 is in 100 place, so it's multiplied by 100. So value 3 has a different value depending on which position it is. Now let's look at the base or radix, number of unique digit in a system. For example, decimal base 10 digits 0 to 9. Binary has got only 2. So we have got 0 and 1. Octal has got 8, base of 8 or radix of 8. So it has got digits 0 till 7. Hexadecimal base is 16. So common digits which are there in decimal, that 0 to 9, those 10 are same, and still 6 are required. So A, B, C, D, E, F. These are the extra letters which are representing numbers in hexadecimal. Similarly, we have got a positional value. Each position is equal to power of base. What do we mean by that? That means 245. So 2 multiplied by 100, because its position is 5. How do we get the value of 5? 5 into 10 raised to 0, 4 into 10 raised to 1, 2 into 10 raised to 2. So 200 plus 40 plus 5 is equal to 245. Now you might be asking why different systems exist, why those different systems are existing. As a human beings, right from our first standard, when we start learning, we have started counting with our fingers, 1, 2, 3, up to 10. So we right throughout our life, unless someone is doing computers, learning computers, it's all about decimal system only, and that's the only numbering system person is learning. That's how the humans are connected with decimal system. Everyone learns decimal system. For computers, computer, it's made up of on-off switches, and those bits become bytes and kilobytes and everything. So there it's all about binary, zeros and ones. So that's about computers. Computers have binary numbers. Programmers use octal or hexadecimal. Why? Because it's much more easy to convert from binary to octal or hexadecimal compared to decimal. So what is the purpose of each one? Decimal is for humans, binary is for computers, and octal and hexadecimal is for programmers. Positional value representation. Each digit position has a weight. Power of base. Examples. Decimal, we have already seen, 345 is represented by 300 plus 40 plus 5. In binary, instead of 10, we have to multiply it by 2's, power of 2. So 2 raised to 0, 2 raised to 1, 2, 3. We will be going in much deeper how exactly it is working. Now, the same rules we will be applying to all bases, whether its base is 10 or 2 or 8 or 16, or even if it is 5. Same rules are applicable everywhere. What are the common numbering systems used in computing? As a human beings, we are using decimal, we are using everyday maths and all the applications everywhere for the out input. Wherever we want to give someone, count something, everything is done by humans in decimal. Binary. Binary is used by all the digital equipments. That's the because making circuit is easy in binary. So binary is used by all computer circuits. In the beginning, octal was used a lot, but as computers expanded, 8-bit, 16-bit, 32-bit, 64-bit. So octal is nowadays just history. Hexadecimal, base is 16. So every 4 bits, 2 raised to 4 is 16. So every 4 bits of binary gets converted to one hex digit. It is used for memories, colors, summary of and what we have done so far. We learn about numbering system, how numbers are represented. We learned about base or radix, common systems that are decimal, binary, octal, hexadecimal. In the next video, we'll be covering start with decimal system. And once we have got a firm understanding of decimal systems, we will be applying same rules to other systems. So stay tuned. See you in the next video.